In this session, we are discussing how are the polynomials represented using the linked list. Polynomials are the algebraic expression that consist of variables and coefficients. We can perform the arithmetic operations such as addition, subtraction, multiplication, but not the division. So how we can represent a polynomial? By using linked list. So what is the representation of a node? So here we have to represent the coefficient, exponent and link. So the node consists of three parts. First part contains the value of the coefficient. Second part contains the exponent value. And third part store the address of next node or link to the next term. Let us take an example. Here the polynomial expression is given and we have to represent into the linked list representation. So for the linked list, we have to initialize it. That is there are two pointers we require, start as well as the last. So we have to initialization both the pointer as a null value. So initialization is the null value. Here also last is the null value. Initialization with the null value. Then we have to create a node to store the value of the first term. This is our first term. So for first term, this position is reserved for the coefficient. This position is reserved for the exponent. Here we have to store the exponent. Here we have to store the linked or address of next node. So this is the node representation for the polynomial expression. So first component we have to for first term of the polynomial expression, this one. So we have to first take the coefficient value. First coefficient value is 15. Then power is 3. So then this one is null. First we have to create the node. For example, the address is 100. Once is created the node, then we have to check whether the linked list is our empty or not. If it is a empty, means start equal to last as well as the start equal to null. So our linked list is empty. Then what we have to make? We have to make that is start as well as the last pointer value is as a newly created node. Then both the first pointer as well as the last pointer point to the first node. After that, what happened? We have to go to the next term. Next term is the 7x square. For that, we have to create a separate node. One more node we have to create by help of the malloc function. For example, memory allocation is successfully done and the memory allocated is 200 address. For example, memory allocation address is 200. Then we have to store the coefficient, exponent, and null. After that, we have to check whether our linked list is empty or not. Right now, our linked list is not empty. If it is not empty, then what happened? We have to make the connection. To make the connection, what are the things we have to do? We have to simple store the address of newly created node to the last next. What is last? 100. 100 next. This is 200. Then we have to make the connection. Once the connection is established, then what happened? We have to make this last pointer points to the newly created node. So how to do it? So we have to remove this one. Then last node we have to make as the 200 value. So now it points to this one. So next term of the polynomial expression is the 5x. For 5x, we have to create a node. Once we created, for example, the newly created node address is 300. Then we have to store the coefficient value, that is the 5. Exponent value is 1. Then it is null. Then what happened? Here we have to store the newly created node. So next we have to store the newly created node. We have to change the last pointer because previously last pointer point to this node. Right now we have to make the last pointer points to the newly created node. So this is 300. If it is 300, now points to this node. Then last term is 10. So for that we have to create a node. Example, the memory allocation is done, the address is 400. Then we have to store the value of coefficient, exponent. Then this is the null. Then here we have to store the 400 value. We have to store the 400 value. Once the 400 value is stored, means connection is established. Then we have to make this node as a last node. For that, we have to remove this node. Then we have to make the last equal to new node. If we make the last equal to new node, then what happened? This is the 400. If it is the 400 means now last point to this node. So this is the our linked list representation of the polynomial. So this is our input is the polynomial expression and output is the linked list representation. So if we know how to represent the polynomial in a linked list way, then it is very easy to perform the addition of polynomials or subtraction or multiplication. So we can perform the any type of operation by using the polynomials. Thanks for watching the video. On the next video.